Our next article for the discussion is discharge over submerged or a droned weir. So before proceeding for the finding out the expression for the discharge, first of all we will need to discuss or we can say that we have to understand what exactly mean by the submerged or droned weir. So if you can see this figure which is on the shown on the right side is a simple demonstration of a submerged weir. So whenever the water level on the downstream side, or you can say the tail water side of a weir, is above the crest of the weir, then the weir is called as the submerged or droned weir. So let's understand this particular definition with a simple comparison between the submerged and unsubmerged weir. So let's take a weir which is placed in any open channel flow. So suppose water is flowing such this way, and this water takes a fall from this location and it continues, and then it takes this kind of shape. However, in case of the droned weir, or you can say submerged weir, this will take a nap like this one, and then it get discontinued over this one. However, if now if you see that this particular is a unsubmerged weir. And this thing is your submerged weir. Yeah. So if you see what exactly I wanted to show, that once the tail water is there, if you see the tail water is below the crest of the weir. However, in another case, the tail water is above the crest. That is why this particular kind of weir is called as submerged weir. So this is your tail water. So tail water, and this is your upstream side. So downstream side is also called as tail water. So for your ease, I am writing down the definition of the submerged weir. So when the water level on the downstream side that is also your tail water is having higher level of the crest of weir, we call it submerged weir. Or droned weir. In such situation, if you can see in this figure, this weir is such that just once it passes through the weir, the water level it goes down by a decrement of capital H minus H. So the water head available just after the weir is a small h. So in order to get the total discharge over the weir, we have to solve this problem in the two section. So we can divide this discharge in the two parts, with a portion between the upstream and downstream water surface. Maybe treated as a free weir, and portion between the downstream water surface and the crest of the weir is can be considered as a droned weir. Discharge over the weir, that is your Q, that is the summation of two discharges, Q1 and Q2. So Q1 is the discharge, that is the portion between the upstream and downstream water surface, portion of water between upstream and downstream water surface, and this will be treated as a free weir. This is your free weir. However, the another part Q2, this Q2 portion is the portion between the downstream water surface and the crest of the weir as a droned weir. So we can write now that Q1, that is Q1 is discharge over upper portion, that is your 2 by 3 CD into length of crest is 1, L. However, we are considering this portion as a 1, so we are using a different coefficient of discharge as a CD1 multiplied by under root 2G capital H minus small h raised to the power 3 by 2. So if you can see H minus H is the this is your free weir. However, the other portion discharge, that is Q2, this Q2 is discharge through the drone portion. So discharge through the drone portion is your small h. Now we can write this equation as CD2 multiplied by area of flow into the velocity of flow. So area of flow is L into H, and then velocity is 2G, and the velocity at this location will be H minus H. So we can write that Q is equal to Q1 plus Q2. So Q1 plus Q2 will become out to be 2 by 3 CD1 multiplied by L multiplied by 2G multiplied by H minus H raised to the power 3 by 2 plus CD2 into L into H into under root 2G H minus H. So in order to get the discharge over a drone weir, we need to use this particular equation. So somewhere you may arrive a situation where in the problems they do not mention that there is a difference in the CD1 and CD2. So if such situations are over there, you can assume a uniform coefficient of discharge for both the sections.